Hey guys, so in the next 3 to 5 minutes I'll be walking us through what data types are in Python and how to use them, understand them properly as well, like in our workflow and all of that. So if you have any questions regarding whatever it is I'll be teaching, or even if it has to do with the previous classes, do not forget to drop your questions in the comment section of the video. Then I will do well to answer them as soon as possible. So let's get started. Data types in Python. So this is my system. I'm currently in my desktop environment. That's where I work from, in this tutorial videos. And if you've installed Python on your system, by calling Python from your terminal or command prompt, if you're using a Windows system, you can run your Python shell. But in this case, I have multiple versions of Python on my system, both Python 2 and Python 3. That's why I have to specify Python 3 if I want to call the Python 3. If I want to call Python 2, I just use Python alone. So let's go straight to the point. I'm using Python 3 in this video, so let's get there. So yeah. Data types. So what are data types? Data types are ways of categorizing data items in any programming language. Actually, there needs to be a way in which the compiler or the interpreter can categorize data items. So a little example, a quick example from our day-to-day activity, how we human beings categorize data is, let's say you and your sibling, you're taking a walk, and let's say you just left a restaurant, and you were trying to get an understanding of what you guys ordered, and let's say your brother or your sister says, we ordered 2 plates of fried chicken. So now you, the listener, you had 2 plates of fried chicken. Instinctively you understand 2 is a counting system for the plate of chicken. How were you able to do this, or how you were able to do this, is because of the way in which the language use, or our language has been trained over time, and our brain processes it, identifies 2 as a counting system for the plates of chicken that we ordered. So we as human beings, we also have a way in which we categorize data items, because that 2 is not an alphabet. Okay, and definitely 2 is not a thing per se. It's a way of numbering the chicken item, or the fried chicken. The fried chicken is the real elements there, while the 2 is a numbering for the item. So that is just to show us that we human beings have a way of doing that. So in programming languages as well, especially Python, since we're talking about Python here, we have a way of categorizing data. And the major data types we have in Python is the major category of data types we have is we have the numeric data types. We have the non-numeric data types. We also have the Boolean data types. So these are the broad classification of it. Of course we're going to narrow it down, but these are the main kind of data types we have in Python. So narrowing it down to the different kind of data types that we have in Python, we're going to be talking about the integer data types. We're going to talk about the string data type. We're also going to talk about the Boolean data type itself, and we're also going to talk about the non data types. And and again, around here we should have something like the float data type. So I think we're good with this. Of course, for the numeric, we have integers. We have the integers, float, and we also have the complex numeric data type. But a lot of us don't really get to like use it, especially the beginners. You know, we don't get to like use the complex data type as this for the first possibly few years, or depending on the project you're working on anyway. So yeah, so these are like the data types we'll be talking about in this video, and let's get right on it. So talking about the first one, the integer data type. So what are integer data types in Python? So this starts with the things like 4, the things like 5, 45 in this case, 7, 10. Like, think of any natural number, so it is an integer, and for all whole numbers are integers. So in Python we also have the positive and negative integer numbers. For example, like -5 is still an integer, but it's a negative integer. So the same thing with -200, it's still an integer, but it's a negative integer. The same goes for 10,000, it's still an integer. So how do we check the data types, or like the type of data type, or get the types of data type in Python? How do we check? We check that by wrapping around any variable or value in Python the type keyword. So when you get the type keyword, boom, you get it, class integer. If you're using anything less than Python 3, you should be getting something like type integer here, but Python 3 upward, they tend to like specify the object-oriented nature of Python, like more focus was on that, like, I think in the design and philosophy, etc. So but this is it. So it tells us like this is a type integer now. So the same with the type of -50, so you get it, should be integer. So the difference between this type -50 and 10,000 is that one is a positive integer and the other is a negative integer. So let's move on to floating point numbers on numeric data type. So what are these guys? So these floating point numbers or numeric data types in Python are ways of representing the already existing like point numbers that we have in reality, like like 5.6, you get 1.5, 1.5, like 2.5, 3.5, and all of those things. So like there are ways of representing them. Okay, there are ways of representing them in Python. So for example, let's take the 1.5 we just mentioned. So 1.5. If you wrap the type around it, you get something. It's a float. Okay, 1.578. You still get float. So like floating point numbers in Python, it's the numbers with decimal points. But do not get this confused. There is still a decimal kind. There's a data type, okay, or let's say a subclass of decimal, okay, but decimal on its own does not occupy a space in the the data types class. Okay, it's more like a subclass. So floating points could take like, I'm trying to explain this in the best possible way without driving so much into memory allocation and computational speed in programming languages. But the idea is this: Python is a dynamically typed language. So in this case, there are like various languages like C, C++, and the likes of Java, etc., where you specify the kind of data type that you have. Like for example, this is just an example. Don't take this. This is not Python. So for example, in a language like C or like C++, you specify, if you want to like define an integer, you tell it like this is like an integer of the value of a. You're giving it a value, yeah, and you can assign the value to it. You declare the variable, you specify the type of the variable, and you are assigning the value to it. However, in Python is dynamically typed. It strives to make it easier for you or beginners to walk around programming, and as such when you type a is equals to 5, the language does not exactly know what you're trying to do at first, okay, but you're not specifying the data type of a. So the system on the background creates memory, okay, for there's a memory allocation for everything that is happening on the system, like every variable declaration of operation or variable assignment. There is a memory allocation that goes into that to support it. So now Python assigns, creates this memory, okay, doesn't know what exactly it's expecting. So if it's an integer, if it's a string, if it's a list, it doesn't know yet. So it assigns this memory to take in anything that is coming, and that is one of the strengths of Python, in that it's easy to read and it's straight to the point. At the same time, it's also one of the drawbacks, because for example, the higher the memory allocation where it's not needed, it's beginning to take a toll on the computational speed of the program at the end of the day. So there are some of the drawbacks you might hear online. Python is a bit slow, Python is slow, and all of those things. But for most of the things you'll be doing at this stage, Python is still so much fast for it. So the slowness or the speed thing is not a concern for you now, and you just don't focus on all of those things just yet. But over time in future, if you have any question, even right now, you can ask me about how memory allocation and computational speed works in Python. So but let's focus on this. This is just to explain to us this. So there is a degree of accuracy that floating point numbers can give us. So if, for example, you want I'm just citing an instance, you want let's say a 300 decimal place number, the bigger it gets, the less the bigger it gets, the more accurate it is. But then there is a constraint with the floating point number, such that since we're trying to control what you want to use, so the decimal point, which is more like a subclass, is provides a larger accuracy to floating point numbers. So but we'll talk about that later. So this is what floating points are. Then we're moving on to complex numbers. So complex numeric data types. So this includes, and for those persons that have done complex numbers in mathematics, you know how that works. However, in Python, we don't have the square root of -1 is not, we don't have a high. We start from j in Python, so that's just the way it works here. So 2j, you know what that means, 2 multiplied by the square root of -1 and all of those things. So depending on the kind of problem you're trying to solve, so Python introduces the complex number to you. So this is you get what you're seeing here. So this complex numeric data type in Python, and you can easily and the type of a, we get complex. So that's how it works, and we're moving on to string. So with the string data types. So what are the string data types? String data types are this numeric and non-numeric data types that are not they are mashed together, this Unicode way of, God, I don't want to make this complex, but strings, let's just assume that like text, like you're reading a textbook and all of those things. So everything inside your textbook is considered a string until it's stated otherwise. So for example, let's say my string, this is what is happening here is a variable assignment operation. My string here is the variable name and this is the value. So my name is Olamigoke Philip. Right, so this is a string, all right, and if I run the type around it of my string, I get a class string. So that is to show us that this is a string. However, a string is not just made up of alphabets alone. You can have numbers there. Okay, like my name is Olamigoke Philip and my number is 08066211567. I'm just citing an instance. So yeah, so if I print out my string, okay, I still get this. So even though these are numbers, it's still a string inside of this data type. So that's how it works in Python. Like a string is made up of A down to Z, okay, and a combination of any of 0 to 9. It's a combination of all of this, and A to Z and all of that, and of course the caps letter also matters. So A to Z, 0 to 9, and the uppercase, both uppercase and lowercase. So we've got them all. So that is that. And let's move on to the Boolean data type. So now these Boolean data types are basically the true and false. They're basically the true and false, values in programming. So the ones and 0, you know how that works. So so 1 and just not the logic gates and all of those and logical operations and that. So the values are what we have in this Boolean. So like 5 is equals to 6, like I said, is going to return false. That's a Boolean value. And 5 is equals to 5, for example, is true. So these are Boolean values. The true and the false, they are Boolean values. So we also have the none. So the none data type in Python is a way of telling it, like, buddy, I'm declaring a variable, okay, and I'm assigning a value to it. However, the value I'm assigning to it, is just null, or like it's none, meaning I'm not giving it anything, just give it a garbage value or something like that. So you're just in the programming language that non-type data or something like that, like there is no value for it yet, or like there's nothing, just give it whatever it is you think. So A is equals to none, and the type of A, okay, it's a non-type. So it's like telling it that A is garbage. However, you can always update the value of A whenever you want. Like you can always update the value of anything anyway. So like be it a string, a number, or whatever, you can always update it. So A is equals to 5, and A becomes 5. However, when A was none, okay, it means that the value is undefined. So these are all I've done in this video is to explain to us the various data types that we have in Python. So let's walk you through them again. We have the integer data type, we have the float, we have the complex, and all of this here are numeric. Okay, all of this here numeric. Okay, so we also have let's say the non-numeric, which we equate to things like the string, okay, things like the none, and let me leave that at it. Then we also have the Boolean, which is the Boolean, which is the true, false values, and I believe I've covered the various data types that we have in Python. So in the next video, I'm going to talk to you about how all of these data types combine together, or the various ways in which they can combine together. So in Python, or like in most programming languages, they are called data structures. These are ways in which, you know, various data types are arranged or collected together. So the one thing I want to mention in this video before we go, before I wrap it up, is that all of these data types that we've mentioned in Python, particularly the string is, like, has a way of, has a way in which you can manipulate them, you can manipulate them. So, like, the string, for example, like, my name is, okay, so you have, let's say, Goke. So, and you get my name is Goke. So, like, all of this string has a way in which you can manipulate them. The same with the numbers, the same with the, like, they just have a way in which you can manipulate them. So I'm going to recommend some read-ups or some articles in the link below, so just make sure you check them out. And I'm hopeful that in this video you've been able to learn one or two things more than you knew earlier. And if you haven't learned anything, I believe it must have also reinforced some of the knowledge that you have already. If you have any problem, or if you have any doubt, or you have a contrary opinion to anything that I've stated in this video, please do well to leave your comments in the description. Leave your comment in the comment section rather. So thank you very much for watching. I really appreciate your time, and see you in the next one. Thank you.